Weijia Zhang is going to be giving a presentation now. He's very well established, having published over 30 research and technical papers and named as an inventor for over 20 patents granted and pending in computer and digital technology. He also serves as technical committee voting member to publish the solution deployment descriptor by Oasis. Oasis, for those of you who aren't aware of it, is an open standards organization, and they are also a governing body for the baseline protocol, which we've had people speak about at previous meetups here. Wade is the vice president of engineering at Wanchain. Wanchain provide a blockchain interoperability platform. This is something that they've been working on for years, and so it's an area that Wade has got very deep expertise on, and he's also been driving a lot of the cross-blockchain interoperability initiatives at the Enterprise Ethereum Alliance, and is the regional head of China as well.
Thank you, Connor. Great to be in this EEA London session, and we just had a great presentation from Julio. It's great. This talk is about cross-chain interoperability, and there are so many things to talk about with cross-chain interoperability. So I'm going to try to make it as rational as possible. And if you have any questions, please just send me a chat link or a chat message so that I can answer them. So the topic to cover for today is, first I'm going to talk about cross-chain concept and some introduction, and then talk about the use cases, and then architecture. And then there are two important things about cross-chain, which is cross-chain decentralization and security, and then talk about some of the solutions, and then go through the EEA Crosschain Workgroup that I have been working on. I'm a co-chair of this work group, and some of the progress have been made with the EEA Crosschain interoperability specifications. So first about the crosschain interoperability. What is a crosschain? That is a platform or a protocol that transfer asset, message, data, and command from one blockchain to another. At this time, as of today, I only see cross-chain transfer of assets available now. But I think in the future, the transfer of data and commands will be available. This will be just like the internet, where you can execute command in different domains. And some of the basic concept here, the source chain and target chain. Okay, when you have cross-chain operation from blockchain A to blockchain B, then you have a source chain that's the original asset, where the original asset resides, and then have a target chain that the transfer asset goes to. And I also have several defined concepts, the native token. For Ethereum, if assets are created in one blockchain, these assets are native assets. And if it's cross-chain from another chain, that is transfer assets or transform token. So they're different from the original native token. For example, if you transfer BTC from Bitcoin blockchain to a ERC20 format, WBTC in Ethereum blockchain, then the BTC is native asset, while the WBTC is the transform asset. And we need to do that separation, this differentiation, because these two assets are coupled together. They cannot be separated. If you kind of burn the other one, then the original asset, then the transform asset get impacted as well. So this brings in the concept of one-way bridge versus two-way bridge. For one-way bridge, right, you would think that cross-chain should be two-way bridge because the asset has to transfer from one blockchain to another blockchain and back. Otherwise, it's not a bridge. But when we say one bridge, we mean the native asset transfer. For example, today, you can transfer BTC from Bitcoin blockchain to Ethereum blockchain. But normally, it's not possible to transfer Ether from Ethereum blockchain to Bitcoin blockchain. So this is a one-way bridge. And then for two-way bridge, we mean that the native asset can be transferred from one source chain to a target chain and then back. So two-way bridge will be used in the EVM compatible blockchains for Ethereum ecosystem. And then direct bridge is another concept where you can transfer assets directly from blockchain A to blockchain B without reliance on a hub or a central governance system. And then also bridge staking and collateral, because bridge are decentralized. And the only way to guarantee the security of bridge is to let the bridge operators to stake some assets to the bridge smart contract. And then if there's something wrong, then the bridge operators will pay that price. And this is one way to secure the bridge. So these are some of the concepts for bridges that connect two blockchains. And then the use cases, we have some work published already, because with EEA's Crosschain Interoperability Workgroup, we have some milestone. And the first milestone is to publish a Crosschain use case document. And this one, I put the link here that with EEA. This EEA website, you can download it directly from there. And this is the work from mainly editors are from me, from Wanchain, and then Kinematics, and also Consensus. It has 12 use cases for Crosschain interoperability. Yeah, and just give some idea about the topology of Crosschain, and so that we can go to the detail of use cases. And if you look at the light blue bar here, there are 3 blockchains depicted here: blockchain A, blockchain B, and blockchain C. And then vertical one, the dash lines, they are enterprises that run different client nodes for the blockchain. For example, enterprise 1 could be running a blockchain node for blockchain A, and then blockchain node for a client node for blockchain B, and then another node for blockchain C. And then there's a relay node. So this is a case where this enterprise 1 could be just a bank. And then there are different blockchains that are established. For example, there could be a Bitcoin blockchain, Polkadot blockchain, or a Ethereum blockchain. And the bank can have a client node running in these blockchains to get the latest state and then the latest information, messages, events from these separate blockchains. And then there could be a relay node that actually do the message and asset transfer among these blockchains and through the blockchain they're operating. And same thing with enterprise 2 or bank 2, they can have 2 nodes running for B and C, and then for enterprise C 3, they can have 1 running for A and B. And we depict it this way because sometimes some blockchains may have permissions. They may allow enterprise A to run on all of these blockchains, and they may not allow enterprise 2 to run on blockchain A. So this bring in permission to the blockchain, the Crosschain operators. And then with that in picture, we can have some use cases. For example, the major ones, the Crosschain DeFi. Today, when we talk about DeFi, we talk about Uniswap, we talk about compound lending and other things. But these are on single blockchain, which is mainly on Ethereum blockchain. And can we expand that to Crosschain so that one user can sell NFT to different blockchains without even establishing account or running application on these blockchains? So there will be Crosschain DeFi. And then we can also have Crosschain key management. Key management is that suppose you have a company and all the people have some company account to manage the cryptocurrency assets. And you want the key management to be confined in the company private network. And then once all the transactions should be signed through keys that are managed by the private blockchain. And then only the public blockchain will take the signed transaction, but you should not sign that in the public blockchain. So with Crosschain, you can have a coupling of public blockchain with a private blockchain, while the private blockchain handle the key management. And then we also have use cases with selective transparency and selective privacy, because different banks, different countries may have different privacy requirements. And that could be encoded, embedded in the private blockchain itself or enterprise blockchain itself, and then the public blockchain will be fully open. And then the Crosschain information syndication, this is a kind of use case where you can have application to access different blockchains kind of simultaneously and get all the information from different blockchains and aggregate the result and present to the user, almost like a Google of blockchains. You can just have one centralized application to access different blockchains. And an Oracle chain, this is a case where you have an Oracle that actually runs as a blockchain. And then you use Crosschain to access the Oracle information provided through that blockchain. And also different countries have different regulation, different laws, different rules. You need to have a kind of a consortium blockchain that are related to different nations. And the data has to be protected to some extent. And also Crosschain Charity, you have one charity event, but you want to accept different assets from different blockchains. And this is another use case where you can use Crosschain functionality. And just a little bit more detail on Crosschain DeFi. You have a user called Alice. And Alice can want to do several things. Well, Alice has an NFT asset, and she wants to sell the crypto asset to multiple blockchains. So Quota is Crosschain asset transfer application. So with Crosschain capability, you just need to say that I want to sell this asset to different blockchains with different currency at different prices, and then the Quota will handle that. And then CDEX is a Crosschain decentralized exchange. Today when we do exchange, we need to do two things. One is that you do the exchange in one blockchain. And second thing is that you rely on a centralized exchange to handle the transaction. With Crosschain, you can just use one application to do exchanges across different blockchains. And then another one is CDAT, which is a Crosschain decentralized asset transform. Transform is different from transfer, because this is a case, suppose you have Bitcoin, you want to participate in some DeFi application or event in Ethereum, you need to convert that BTC into a ERC20 format. So the CDAT is to convert BTC to ERC20 format like WBTC on Ethereum blockchain, and that WBTC in its ERC20 format can participate in a lot of the DeFi application in Ethereum blockchain. So these are all different use cases. And this is the how it works, the detail works. We'll skip this one. Yeah. And then going back to Ethereum, Connor is very familiar with this diagram. This is the Ethereum architecture from EEA. We added some Crosschain components over there. The EEA label Ethereum architecture as layered. So there's a network layer which is at the bottom, and this mainly is a P2P connectivity, and this is the same as a TCP/IP. And then there's a core blockchain which handles the various transactions, and then the execution, and then the consensus at this level. And then there's an enterprise layer which mainly have a privacy, performance, and permission. And then we also have tooling and an application layer. So the difference between public blockchain and the enterprise blockchain for Ethereum is that the Ethereum focus on privacy, performance, and other things. And with Crosschain, we added a column which is in green color here, which is on the right column. So we have to add a lot of Crosschain tab, a lot of component Crosschain tab, Crosschain consensus, Crosschain bridges into the right-hand side here. And also there should be privacy zone as well. So these are all in the use case document that we publish, and you can download it from there. So there are two things that are very important. One is decentralization, and one is security. So let me talk about decentralization of Crosschain interoperability first. I kind of divided these into layers. For example, in the blockchain layer, we have P2P connection, and then in Ethereum blockchain, in any blockchain, there should be some boot nodes. These are the nodes that when you have a new blockchain client coming up, it's going to talk to the boot node first And then from that pool node, it's going to find the other peer nodes, and then it's going to do peer-to-peer connectivity, and then it establish the connectivity to the blockchain. So when your first question is to ask is that where are these pool nodes? Who control these pool nodes, right? So centralized pool nodes are the ones that controlled by one single entity, and it has low cost of changing it. And decentralized ones are that the pool nodes are managed by community and it's trusted. Many people did not go to think about that, but this is actually very important for new blockchains. Like for blockchains such as Ethereum and Bitcoin, we know they're stable, they're trusted. But if somebody construct a new blockchain, and if you need to build a bridge to that blockchain, you need to think about the pool nodes they are providing. So that's one thing. And second, the one layer. And second layer is the consensus layer, right? When you have blockchain, you have a source blockchain and then the target blockchain. And the source blockchain and target blockchain will have its own consensus. And these consensus may not be the same. So the question asked is the consensus protocol permissionless and trustless, right? If a blockchain is using POA, proof of authority, or BFT, and with very limited amount of nodes, and these are very centralized, because things that can go wrong in source chain will impact cross chain in the target chain. So it's very important to ensure that every chain that you are connecting with is decentralized and trusted. And then if the consensus POW or POS is with a large number of participation, then it's kind of a decentralized. And then the bridge layer, bridge is the one that connects two blockchains, right? And then there are many questions to be asked, which is who administers adding and deleting relayer nodes. Relayer nodes are the one that convey the message from blockchain A to blockchain B. And then are they penalty or slashing for relayer nodes sending invalid transactions? And then this one is centralized, is single administrator, and then no slashing for bad relayers. And the decentralized one will be the one that actually have multiple administrators, and also they have slashing for relayers doing the wrong thing. Yeah. Another thing that's often neglected is the smart contract ownership, because when users interact with smart contract, they thought that smart contracts are decentralized, is guaranteed by the logic, but they did not look into the detail about who owns that smart contract. So when you do the bridge, when you do a bridge to connect to a smart contract, you need to ask whether who owns that smart contract, who deployed the smart contract, and who does the smart contract owner have the right to upgrade or to kill some of the function of the smart contract. Yeah, and then normally if a smart contract is owned by a single EOA, EOA means externally owned account, then there are two issues here. First, that EOA is owned by a single person, and that person have the right to change the smart contract. And second thing is that EOA, if it's not in hardware wallet, it could be hacked, and it happened many times already, where an EOA account was hacked by a hacker, and then it changed all the DeFi applications. And then if the DeFi application is hacked, it impacts cross-chain application, cross-chain bridges as well. Yeah, and so that's why we need to have a smart contract, need to have decentralization in it. Yeah, and then the Oracle decentralization, today, of course, we know we have Chainlink, the banned protocols. I think it would be good at some point to have decentralized Oracle, and this Oracle could be in the blockchain format. So for decentralization of Oracle, it need to remove the dependency of proprietary Oracle that are controlled by a single party. Another thing that's another layer that's important is the web services. Normally, users use a MetaMask, use a wallet to access the DeFi application through a web server. And the web server normally is centralized, and to make it fully decentralized, you need to have a decentralized web services. And this will be, I think, some of the Web3 and other things are going on right now, so that there's no dependency on a single server. Yeah. So decentralization important. We covered the decentralization, and the next thing is security. I got the question. Let me. Yeah. Okay. Thank you, Connor, for that link. Yeah. So because Crosschain covers several components and cover multiple layers, it covers the source chain, it covers the target chain, it covers the bridges, and it also has staking, other things. So there are many security factors to consider. First, you need to consider security in a single chain. You need to have a source chain security. Every time you want to connect or to cross-chain to a chain, you need to make sure that chain is secure. Because if you connect to an insecure blockchain, then later on when the asset is transferred to the target chain, and then the insecure chain get hacked, then the asset on the target chain will be impacted. So need to look at the source chain, look at the target chain, and all the single chain security factors that need to be considered are relevant to cross-chain as well. And then there need to be consideration for bridge security, and then also security for components of various cross-chain layers. I'm going to talk more about that. And then staking and slashing, and then randomness. I'll talk about that. Yeah. So for source chain and the target chain, normally smart contracts are deployed to source chain and the target chain. And in these, there are some security attack on smart contract, and some, for example, the greedy contract. Greedy contract actually lock funds indefinitely. So these are the case where you send the asset to that smart contract. It doesn't mint the asset on the other side. And then the prodigal, this is a case where contract can mint assets to arbitrary users, and this would cause a loss of fund. And suicidal, this contract doesn't have enough permission for the function, and then they get killed by a random user. And this, we have cases for that for Ethereum blockchain. There have been loss of funds due to poorly written smart contract. So the mitigation is to follow secure programming procedure, and then do the security audit, and then also phase testing. You have alpha test, the beta test, community test, and then gradually release the platform. And then there are cross-chain specific security consideration. For example, collusion. Collusion is a case where multiple bridge nodes actually collude and steal the fund from the cross-chain operations. And because bridge is decentralized, right? And it's permissionless. You have different people join as a bridge node, or as a relayer, or as a storeman. You need to make sure that they do not collude. And one of the things to do is to sue multi-party computing, and also sue the trusted bridge operator. Multi-party computing allows a group of people or a group of nodes to join into a bridge operation, but you have to have over half of the node to sign a transaction to make it going through the other side to unlock a locking account. And also finality, important for cross-chain, because normally the cross-chain asset works like this. You send the asset to a source chain smart contract. That smart contract lock that source chain asset, and then on the target chain, another smart contract detect the event on the source chain, and then mint the same value of asset on the target chain. And if there is no finality consideration, what could happen is that the source chain asset is not fully locked yet, and it's not fully finalized yet, but the target asset has been minted. So finality is an important factor to consider for Crosschain. And also rollback, what if the source chain actually get rollback, what will happen to the target chain? So many consideration for that, and the mitigation could be a trusted bridge operator, MPC, and the rotation of bridge node. This is a case where every month or every week, there will be a new set of bridge node to operate. And this will kind of minimize the chance of collusion. These nodes don't know each other at all, and also have slashing mechanism for that. Yeah, and then another thing is the factors to consider for cross-chain emergency handling. Things could happen because if you have a bridge operation that connect 10 source chains with 10 target chains, and one of these source chains could have something happen, and target chain, same thing. Some DeFi may get hacked, the source chain may get forked or rollback. So there should be some emergency handling mechanism considered. One is to pause the bridge. Okay, if it's possible to pause the bridge, and then also taking snapshot of blockchain states. This is if something really bad happened, can you reimburse the asset that get impacted? So if you have a snapshot of the source chain and the target chain, and before the incident happened, that will help a lot. And also capping the bridge. You don't let the bridge to be fully open-ended because you have a stakes put into a bridge, right? Suppose you put 1 million to a bridge, then the traffic should not exceed 1 million for that. So this is to capping the bridge to put the quota for the cross-chain operation. If there are too much transaction, they reach over the quota, then the transaction across the bridge should be stopped. And also should have an effective upgrade path. If something happened, there can be an upgrade path for that. And also staking and slashing mechanism where people who want to operate on the bridges need to put some stake in it, and then there should be a slashing mechanism for that. Yeah, now going to, so we talk about decentralization, talk about security, going a little bit to the solutions. And there are many cross-chain solutions that have been published or advertised. I think I'm going to focus on the, for this presentation, I'll focus on one, which is Wanchain cross-chain operation. They spoke about this Cosmo Iron network and different other things, near network. But just today, I just focus on one. So Wanchain is a cross-chain focused project. And it was established in 2017, and the main goal of Wanchain is just to build bridges. So 2018, June, July, we built about 3 years ago, we built the first bridge to connect Ethereum with Wanchain, and then we built a bridge to Ethereum, to Bitcoin, and then built to EOS, Litecoin, other blockchains. So basically, Wanchain just built bridges to connect different blockchains, and then to make them into ERC20 format, and this ERC20 format token can participate in different DeFi applications in different blockchains. And this is originally in the Wanchain's white paper. So the thought is that Wanchain will be a middle tier that connect the private blockchain at the bottom and then public blockchains at the top. So so today we have already built a trusted bridge that are able to connect with Hyperledger, with Basu to Wanchain. And then we also provide the capability to connect to Ethereum, Bitcoin, different altcoins together through two-way bridge or a direct bridge. Yeah, and this is a more detailed diagram. So on the left-hand side are devices. So we have blockchain application. These could be mobile apps, could be web app application, and could be desktop application. And these applications can directly connect to blockchains or connect to blockchain through some cross-chain gateway. And then on the right-hand side, there will be different blockchains connected directly through some layer nodes, and then also blockchain, cross-chain hub. This could be Wanchain or could be another Ethereum blockchain, could be connected through the hub to different blockchains here over here. Yeah, and then Wanchain has been operating quite well, very decentralized. So the way Wanchain works is this: every month there's a new selection of bridge node. We call it Stallman node. So I think around every month on the 6th, there's a Stallman open enrollment where it's fully permissionless. Anybody can join a blockchain bridge node, and then they just need to put the staking to the smart contract, and then there's a separation of work account and the staking account. So the one who runs the blockchain node does not have control on the staking account. So the node operator cannot steal money from the staking account. So people put the staking into Wanchain bridge node, and then they get selected. So there's a selection process, and then we use MPC. So every time we select 25 nodes as a Stallman node, and out of these 25 nodes, they need to be 17 to sign smart contract, to smart contract transaction. And then these are done by Schnorr and the ESD, DSA key share signing. And then the private key will never be generated. And so each Stallman node has its own key share, but they don't have the full key. And they sign a smart contract. And then this is how it works, okay? When they start working, they sign contract transaction individually, and then they aggregate the individual contract into an overall transaction, and then they send the transaction to the target chain to mint the asset to be generated. Yeah, so this is Wanchain solution. It has been operated for 2 or 3 years. It's been doing very well. We have a direct bridge. We have a two-way bridge, and many tokens have been supported by Wanchain for Crosschain operation already. And then one of the issues we found that with Crosschain operation is that there's a lack of standards. There's because every time when you try to bridge to another blockchain, we always need to rework our solution because different blockchains have different different specifications, different APIs. You have to do it very, very differently, different consensus as well. So I think 2 years ago, we presented to EEA about building some specifications for Crosschain operation. So the justification or background was that this was 2 years ago. I think it's still very, very valid. There are challenges when you try to bridge different blockchains, particularly when these chains are heterogeneous and incompatible. So there's a challenge over there. And then the EEA members view interoperability as a top takeaway based on one survey at that time. And then for outside EEA community, there's increasing interest for interoperability for blockchains. And I think this was 2 years ago. Today, when you look at the Crosschain capability, Crosschain bridges, it become a must-have now. It's a top thing for any new blockchain. So every new blockchain is trying to build a bridge for their blockchain so that the asset in their bridge in their Crosschain can be sent to other blockchain to be participating in dApps over there. Yeah, and we believe that the current state of blockchain, the connectivity or interoperability is similar to the pre-internet era where PCs work alone. So we need to have a almost TCP IP type protocol to connect different blockchains, just like internet connecting PCs. So we presented this to EEA board and presented it in face-to-face meeting, and Connor was in that meeting as well. So a couple of things have been done. First, it was approved that we form this entity, and then we have a bi-weekly conference call, and we also have a GitHub repository. This is ongoing now, right now. If you have interest, please let me know and or let Connor know, and we can get connected and you can participate in this. And then we collect solutions from consensus, from Wanchain, from telematics, and then kind of look at their solution to see what things are common, what components are common, and we come up with the use cases, and we actually publish that the use cases already, and we also extend the existing enterprise Ethereum architecture to include cross-chain interoperability, and that the diagram you see is coming out of that. And then we also, we mapping the components, different components to cross-chain use cases, and then we publish it. And then we also submit the cross-chain identifier specification, this EIP 3220 to Ethereum, so that we can have a common way of defining cross-chain identity. Because today, the cross-chain ID is defined by EIP 155, which is a single number. And that single number is not unique enough. And that number doesn't tell you much about the blockchain. So EIP 3220 allows a bridge operator to look at the a blockchain through a 32-byte unique identifier and figure out something on that blockchain, and also have a way to verify that blockchain to make sure that it's authentic. Yeah, and also we also working on the smart contract registrator that's going on right now in progress, and we also have a relayer function specification that's under review, and also we have a consensus is doing providing a specification for cross-chain function call, and I think after this meeting we're discussing that as well. So it's in good progress. So overall, I think the cross-chain interoperability work group is working on the specifying and make common things specified so that we can do cross-chain operation faster and easier and in a more consistent way. Yeah, and I think we get a lot of help from people in EEA, on people from different company as well. So that's an acknowledgement. And I think I want to stop here and take questions from audience.
Cool. So Weijia, I'll jump in just to get things going. In terms of if people want to get involved but they're not members of the EEA, what are kind of the ways in which they could potentially engage or learn more about the work, or perhaps look at some of the work that Wanchain's been doing?
Yeah, well, thank you. Yeah, it's first about Wanchain. Wanchain is a public project, open source project. So there's a wanchain.org. You can get there, and the GitHub is there. All the source code are there. So it's just like any other blockchain project. You can get to it, or you can contact me for Wanchain, no problem. And then for EEA, because EEA is a member-driven entity, so I asked that question to Dan and Ron in the past as well. You have to be a member to contribute, but some of the papers we published are non-member, are open, are public, open to public. So I think you can view and get information that are published, but you cannot contribute to it. So you have to be a member for that. Yeah.
Cool. So I know that was certainly one of the questions that someone had asked about how they could get involved there. But I'm sure too as well, if someone read the paper and wanted to ask some questions, you'd be happy to respond. Okay, so a question from Sharif. Have you addressed issues like one chain using sharding and interoperating with another that doesn't?
Yeah, that's a great question. I think we are aware of that because sharding itself is not complete yet. It's still dynamic. And one thing we are thinking about that is that if we have with sharding, Ethereum will become a shard, right? So then you have different shards for Ether2. And one reason we have this EIP 3220 is with sharding consideration, because with this 32 byte, right, we can make sharding, we can identify each shard actually, so that you can bridge to a shard, not to a blockchain. You can bridge to a particular shard. So that Crosschain ID will represent a shard rather than the whole blockchain. And then you can treat the sharded chain as a private blockchain for that case. But we do not have specific as how you can link our specification to the sharding specification, not at that level yet.
Cool. And another question, this time from another one from Makarand. Does this working group work on interoperability of other blockchains, or is it Ethereum only?
Yeah, it's with other blockchain, and that's why we welcome other blockchain to join us. We actually talked to Polkadot, we talked to Cosmos, but it's kind of interesting. They do not join EEA community, so we haven't get their presentation in EEA Crosschain Interoperability Workgroup yet. But the specification is supposed to be heterogeneous. It should address both Ethereum and EVM type blockchain and the other blockchain as well.
Cool. And then another question, this time from Roy, who is wondering about the ownership point. Is it not then fully decentralized if ownership is always validated or asked for? Instead of relying on code, we're going to put dependencies on static data. So is the question there that because you're, was it asking for ownership rather than it being done programmatically, so you have a dependency on there? So, sorry, Roy, if you're just able to, is that kind of, you know, in line with what you're asking?
Yeah, I think talking about ownership there, I think that's a great question. I talk about ownership.
Yes, that's the one. Yeah, you got it. Yeah, that's the question I was trying to ask. Sorry, yeah. I was in a delay.
Yeah, I talk about ownership in, I think, 2 or 3 places. One is the ownership of smart contract, right? Who owns that smart contract? Okay, so smart contract is a code. If because smart contract are open, so it's all about math, so it's fine. It's fully open. But then whoever's deployed the smart contract is the owner of the smart contract. He or she can change things, right? So when I talk about ownership, I mean that is that ownership still maintained by one person, or if that person give up their ownership and make it null so that nobody can change it anymore. So that's one consideration. And second thing is that when you have a EOA, externally owned account, will that account be used to control the smart contract, right? If you have EOA account, then that EOA, if that EOA account can be used to control or update a smart contract, then you need to have something to consider over there. Need to make sure that account is trusted. And then there is also ownership about bridge node, the node that actually handle the transaction from a source chain to a target chain. And whoever operate those bridge nodes have ownership to the machine they have. And these machines are offline. So to address the ownership over there, you need to make sure that the owner of those bridge nodes are kind of trusted. And if they are not trusted, you need to make them to put stake in the bridge they're operating. And you also need to put the multi-party computing over there, so no single person can do bad things to the system. You have to overcome half of the bridge nodes to do collusion to the system. And also you can randomly select bridge node so that every time there's a new set of bridge node to make collusion even more difficult. Yeah, so I see another question. Yeah, are the Crosschain DEX available in market based on EEA workgroup work? Not yet. First, we try to build the specification. So there'll be several things coming up. First is the specification need to be done. Then the way EEA works is that EEA itself does not work on the solution itself. So the specification will be adopted, endorsed by different companies, and then they build the bridges. And then from the bridges, then different projects can build the Crosschain DEX. That's step level. So there will be a specification, there will be a Crosschain bridge, and then there will be a Crosschain DEX for that. Yeah, but at this time, no, not yet.
Okay, so we'll if you can just quickly answer one last question, then we're going to wrap up. You mentioned that you need a protocol like TCP/IP. Is it layer 1 or layer 2?
Yeah, this is not layer 1, this is not layer 2, it's Crosschain. Layer 2 is the one that bundle with the layer 1, right? So this is a communication between two blockchains. So when I mean TCP/IP type, I mean that different blockchain have to agree on protocols, right? For example, what is like today, when you have a PC connecting together, you have IP address, right? And then you have domain names. So those need to be specified, TCP and then HTTP and different protocols. And well, that's what I mean. You need to have all the blockchain agree on certain protocols. And this include the identification of blockchain name, and then the communication message format, and also the command format, the finality format. How do you let the other chain know that you are finalized? So there are a lot of things that need to be spec'd over there. I do not think EEA can do the whole job by itself, but at least we can start this one.
Thank you, Weijia.
Thank you very much.